All righty, why don't we get started? So welcome, everybody. I'm Tom Lauwers. I'm the founder and CEO of BirdBrain Technologies. BirdBrain is a small educational robotics company in Pittsburgh, Pennsylvania, devoted to inspiring deep and joyful learning experiences for all students through creative robotics. And today I'm joined by Aparna Brown, our Director of Operations. Do you want to say hi, Aparna?
Hello, everyone. Thanks so much for being here with us. As Tom said, my name's Aparna, and I manage the operations at BirdBrain. We're a tiny team, so you've got a third of our company here with you. I'm going to turn my video off so I don't distract you from Tom's presentation, but I'm going to be active in the chat, posting links to things Tom's talking about and answering your questions. So please ask questions in the chat, and we look forward to interacting with you.
All right, thanks, Aparna. So this talk is going to be about 20 to 30 minutes of me explaining about the Finch Robot and also about remote robots, which is the technology that you're going to use today to program the robots that I have here in the studio. So you're going to be doing some actual kind of virtual hands-on robotics today by programming real robots from wherever you're located. So here's the link to the slides. I'm going to introduce the Finch Robot 2.0, which is the robot that you're going to be programming today. I want to talk a little bit about our learning materials and also about some no-cost options that you can use to access the Finches, either for yourself or for your students. And then I'll talk about remote robots and get to kind of instructing you on how to actually program them. And then hopefully we'll have a good half hour where you can just explore the potential of remote robots. All right. So the Finch, the original Finch, so the Finch 1, was developed at Carnegie Mellon University way back in the late 2000s. And its mission was to be an engaging tool for students to learn computer science. And the research behind that mission was really focused at the time on high school students and college students. Now, BirdBrain was founded in part to commercialize that original Finch robot. And over the last decade, as we've seen, coding go into middle school, elementary school, the original Finch had adapted, and you could start using it in elementary school, middle school. But a few years ago, we realized that it was time to do kind of a hardware update. So to really make a revolutionary update to the Finch robot's hardware itself. And so we took all of the feedback that we've gotten about the Finch 1 from thousands of teachers and students using it in their classrooms, as well as kind of the understanding that there was so much, new capability just in the hardware space. If you think about what's possible in consumer electronics now versus 10 years ago, it's quite a bit. And we integrated all of that to make the Finch Robot 2.0. And we launched that last December. So the Finch Robot 2.0's mission is all about bringing computer science and computational thinking to life from kindergarten all the way to college. So it works with students who are not yet reading, and it works with college computer science freshmen and sophomore taking Python or Java classes, and everything in between. So the way we make that work is by kind of thinking about the Finch as a low floor, high ceiling tool. So by that, I mean that it is easy to get started with. An absolute beginner can get started with it. But as you learn and as you grow, you can keep doing more and more with it. So one way in which this kind of low floor, high ceiling philosophy manifests itself is in terms of the programming languages that we support. So here we have two programming languages. One is called Finch Blocks. It's an icon-based programming environment for very young students. And the other is Java. And what's interesting about these two is that they actually make the Finch do the same thing. They make it go forward and backwards. Now, if you're programming it in Java, you can definitely do a lot more with the Finch at the high end. But at the low end, it's this, you can make the same behavior with either environment. So let's dive into those a little bit more. So again, if you're looking at using the Finch in kindergarten, first grade, second grade, you can use Finch Blocks. Finch Blocks is an app that works on Windows, Mac, Chromebooks, as well as on iOS and Android devices. it actually has 3 levels kind of built into it. So even within Finch blocks, you can adjust the difficulty or adjust kind of how much is exposed to the students. So level 1 is all about kind of atomic actions. So just move forward, turn right, make your beak red. In level 2, we introduce the idea of parameters. So they can set things like they can go forward 15 centimeters or turn the color of the beak some arbitrary color. And then in level 3, we actually introduce some basic control structures. So there are some wait untils, there's waits, there's loops, and there's events. So they actually can start learning about these more interesting computer science concepts. Kind of at the 4th grade and up end, or 3rd grade and up end, you can introduce the Finch using blocks-based coding. And we actually have a wide variety of options. So Bird Blocks is a tablet-based blocks environment that we have developed. So it works on both iOS and Android devices. And if you're familiar with Scratch or MakeCode or Code.org or Blockly, all of the environments that we support are similar to those environments. So they'll look pretty familiar. So Bird Blocks works on tablets. Snap works on computers, so Windows, Mac, and Chromebooks. And in both Bird Blocks and Snap, the interaction with the robot is live, and it's happening over a Bluetooth link. So when you tap on a block or click on a block or a set of blocks, you can instantly see that happening on the robot. And so this sort of live coding allows students to playfully explore what they can do with the Finch. They can, assemble portions of code and just see what happens by clicking on them. And that's what you will experience in the Remote Robots Playground as well. So you will be using an environment called NetsBlocks that is very much like Snap, that's pretty much based on Snap. And so you'll be able to see what live coding feels like when you're using it with robots. And then lastly, we have MakeCode. Now, MakeCode is a blocks-based environment where instead of it being live, you download the code to the robot, and then the robot runs independently of the computer. So once it's downloaded, that robot is going to run that program essentially indefinitely, or every time you turn it on. Now, what's really nice about MakeCode is it has a toggle switch so that you can switch it into text-based coding, and you can see what the blocks look like in either Python or JavaScript. And so it's a great transitional environment. I really recommend it for kind of middle school students who are kind of at the point of going from blocks to text, or where you're thinking about, they may be taking a Python course in a year or two. MakeCode runs in the browser, and it runs on Windows, Mac, and Chromebooks, and Linux computers as well. All right, so that's a little bit about the blocks. And then at the high school end, college end, you can program the Finch in Python. You can program it in Java. These are happening over Bluetooth connections, and so that means that basically that programming is done in standard Python and standard Java. So if you're using the idle Python IDE or NetBeans or Eclipse Java IDEs, you can use those with the Finch robot, just like you would any other Java or Python projects. The Python support that we have works on Windows, Mac, and Chromebooks. The Java support currently works on Windows and Mac only. And then we've actually been developing some ways where you can write your own smartphone or tablet apps for the Finch. So we now have support in Kotlin and Swift, which are 2 programming languages used by developers to write their own apps. So again, sort of high school or college end, you can start doing some things where you have the students write their own apps that control the Finch. Okay, so the actual robot has quite a few hardware features. So we talk about a robot as something that senses its environment, thinks about that sensory or processes that sensory information, and then acts on the environment via outputs. So let's talk about the outputs first. As a robot, it drives around. It has 2 wheels. Those wheels have encoders, which means that the robot knows that it has moved, for example, 10 centimeters or turned 90 degrees. And so that allows the robot to draw shapes accurately and do things like that. It has a lot of LEDs. It has a beak LED in the front that's full color. It has 4 tail LEDs that are also full color. And then it has an LED array, a 5x5 array of LED lights that you can use to make emojis or characters. And that's in the tail on the microbit, which is something that I'll talk about in a second. It also has a buzzer, so it can make different sounds. And then it has a marker holder, so you can place a marker in the center, again, to have it draw shapes. And that's something that we'll explore a little bit also later, because one of the robots I have here has a marker mounted in it. And then lastly, it has a plastic brick adapter. So you can put your favorite plastic bricks on the top of the robot and kind of build on top of that. In terms of its sensing, in addition to the wheel encoders, it has sensors that can track lines. It has sensors that can track light levels. So you can have it, for example, follow a flashlight beam. It has a distance sensor in the front. It has a compass, so it could always drive north or south or east or west. It has a 3-axis accelerometer, which is a sensor that allows it to detect its orientation in space. So one of the fun things you can do with the Finch is like pick it up and make a musical instrument where it makes different sounds based on how you're tilting the robot. It has a couple of buttons, and the Finches that are shipping today also ship with a new sound sensor, which is like a clap detector, detects loud noises. So, like I said, we've built the Finch based on feedback from literally 10 years of the Finch 1 being out in the field. And so we really tried to make sure that it would work in classrooms, and we designed it for classrooms. So it's designed to be durable. It's designed to drop off a desk. It's designed to be stepped on. Being stepped on was actually the way that our old Finch robots failed most frequently in the classroom. So we made sure that the new ones, you could step on it without harming it. It has a battery life that will last a full classroom day. And it's built around something called the BBC Microbit, which is a wonderful device that was launched a few years ago that is actually stuck into the Finch's tail, and that gives it these Bluetooth capabilities. It gives it some of these sensors. And it's something that as a standalone device for learning coding with physical computing is already pretty powerful. So your schools may already have the microbits, or you may be able to use some mixture of microbits and Finches in interesting ways or interesting activities. And then lastly, and maybe most importantly, it comes with a lot of learning materials and support for teachers. So a philosophy that we have at BirdBrain Technologies is that our products are not just about a robot or a piece of hardware, but they're really about trying to inspire those learning experiences that I talked about at the beginning. Right? They are about making sure that that you as a teacher and your students can succeed with the robot. And so we make sure to wrap our hardware and software with activities and curriculum and professional development courses that are free for you to take, self-paced video PD and tutorials, so that we are maximizing the opportunity to use them effectively and well in the classroom. So I want to talk a little bit about those and how our learning materials are set up. So each of the languages that I talked about previously kind of have this level of materials developed for them. I'm just going to talk about the materials for Snap and just kind of show you, do a quick tour of them. But if you were to use Finch blocks or Java or Python, you would have this kind of same level of depth. So if you were to learn, or if you wanted to use the Finch with Snap, we would have, we have coding tutorials for you or your students that take you through how to set up the robot, how to make it move or turn, so how to make it use all of the different outputs, how to make it use all the different inputs, all the different sensors. And then we actually get into how to use control structures or randomness or variables or lists or timers, and just sort of a sequential kind of set of tutorials or curriculum that your students can follow and that you can follow. We also have a set of activities. So we have about 30, a little bit more than 30 at this point, activities. And these activities actually link to the tutorials. So if I were to complete my moving and turning module, so I'm at the end of it, it actually links to 3 activities that I can now do based on my knowledge of how to move and turn the Finch. And then lastly, we have quite a few resources for you as teachers. And I'm going to talk a little bit about a few of these. So we've got some printables that your students can take or that you can print for your students, like the descriptions of the Finch blocks in a blocks-based programming environment. Here's a tutorial on making your own Finch remote robot. So if you like what you do today, you can actually do this yourself. You can set up the Finches to be remote. We have a list of standards and show you how the Finch aligns with Common Core and CSTA standards. We have a reading list. So this reading list is absolutely a wonderful resource for you. It basically introduces you or it shows books that have been kind of curated by Aparna and her daughter. So they've read all of them that are segmented by grade level and by whether they're fiction or nonfiction, and they can introduce, or the books are for introducing either computer science or robotics or engineering design. And then we have these online PD courses, and I just want to show you those real quick. So we have a course on Snap, for example. So if you wanted to learn Snap, here's a self-paced video PD course that's completely free to access, that has 21 videos where you learn all about how to use the Finch and how to make it work, and also how to use the Finch to introduce computational thinking in your classroom. All right, so heading back to my slideshow here, I've talked about the PD course. I've talked a little bit about these. So the CSTA standards, we have those on our website now. I've also specifically created, for those of you who are from Georgia, a K-8 Georgia CS standards crosswalk. So I've gone through at least the K-8 standards for Georgia and linked those to Finch activities and Finch capabilities. And then, we have, a link to research articles about the original Finch, so about the Carnegie Mellon research, and also about research that other people at other universities have done around the Finch. And then finally, a grants page. So the grant page is a pre-written grant guide, as well as a list of national grant giving organizations that you may qualify for. So if you're looking for ways to apply to a grant to fund a purchase of Finch robots, you should definitely check out the grant page. And sort of on that note, I also wanted to mention 2 programs that we have to allow you to apply for Finch robots at no cost. So the first is this demo program. And the demo program, I think Aparna's already mentioned it in the chat, but just to emphasize that, if you're an educator in the United States, we will send you a Finch robot for 60 days just to try it out at no cost. We pay for shipping both ways. It's something that we kind of started or accelerated during the pandemic because we feel like the best way to learn about our robots is to get a hands-on experience with them. But we have no intention to stop using it and stop providing it. It's actually a great program for you to learn how our robots work. The other program is the loan program. Now, the loan program is targeted and it's application-based, and we essentially loan out flocks of Finch robots for you to use with your students. And we specifically want applications where you will use those robots to catalyze computer science learning at your school. So to act as a catalyst, because they're loans, so you only get them for maybe a few months, and that you specifically use them to serve underserved populations. So if you're if you're working with an underserved population, or if some of the students at your school are underserved, you should definitely consider looking at the loan program. Now, we used to have a very kind of standardized application process where, in April, May, and June, we'd kind of collect applications and then we would send them out for the next school year. The pandemic has the pandemic and the transition to Finch 2.0 have sort of thrown that a little bit. but we are, I think Aparna can correct me about this, but we are planning to accept applications or kind of accepting applications on a rolling basis at this point for the next school year. So please check that out, especially if you are serving students who are traditionally underserved. And again, if you're accepted to the loan program, it is absolutely free for you. Like, again, we pay for shipping both ways. All right, so let's talk a little bit about remote robots, just to give you a brief explanation of how they work before we get into actually programming them. So the idea of remote robots was certainly inspired as part of the challenge of the school closures of last year. So in March of 2020, I started working on this idea, and within a few months we had something working. But the idea is, I have some robots here. You're in Georgia or elsewhere, and I would like you to program those robots. So how do we make that happen, right? And we've made it happen, and we've seen it work in quite a few classrooms in the last year. And so I want to talk briefly about the difference between it and one-to-one robotics, which was another thing that we saw during the pandemic that people were doing. So in remote robots, you have the robot and you want students to program them over the internet. And in one-to-one robotics, everybody's got a robot, but you're all in different places. You're all at home or elsewhere, and you still need to teach or coach them effectively. You can't just walk around the room looking over their shoulders, and so you need some tools for doing that. And it turns out that there were also some tools developed for that use case. I'm not going to talk about them except to mention that if you're interested in that, we can talk about it. There are tools for helping with kind of remote teaching where the students have the robots also. And then what we saw, especially in winter and spring of this year, is hybrid scenarios where some of the students were programming robots that were in classrooms, but they were doing it so from home, while you had other students who were actually in the classroom programming robots. So how do you use remote robots as a way to engage, the remote portion of your class? And it certainly worked well in that scenario. And so when I think about what will happen, as schools hopefully go back to normal in fall or mostly normal, I definitely still see use cases, especially around the hybrid scenario or possibly around access. So when you have remote robots, you don't need all of that many of them to provide access to quite a few students. So, if you have 3 robots set up, you can have students kind of filter in at a station or perhaps online as part of their homework and just log in for 10 or 20 minutes and program those robots. All right, so why did we develop this? Why not just develop a simulator? So to me, I think it's really important to program something in the real world that in terms of the benefits of physical computing, those benefits come from the understanding that you're programming something that's real in the real world. Like a simulator, to me, isn't really any different from just going on Scratch or on code.org and completing kind of software-only programming by making an animation or a game. And I mean, let me just say, those are actually wonderful coding experiences. It's just that I didn't see, a simulated robot that we would develop or simulation software that we would develop as adding meaningfully to what was already out there. Whereas something like remote robots was different and new and added something. We also sell a robotics kit, the Hummingbird robotics kit, and it's configurable in millions of different ways. And so there's no way to really simulate that at all. And then again, this equity component of remote robots, you don't need to have the robot at home. The students don't need to have a robot at all. They can program it remotely, and you don't necessarily need to have as many robots when you're doing it in a remote robots setting. So it does make it easier in terms of access to provide more access to more students, even if that access is definitely more limited than if they had the robot themselves. Okay, so again, the remote robots setup that you're using today, it will work with both the Finch Robot 2.0 and the Hummingbird Robotics Kit. All right, so how does this work? So I'm going to send you a link that has a block-based project, and that block-based project will have a few different blocks that control our robots. And when you click on one of those blocks, it sends a message over the internet to another blocks-based project that I'm running here in the studio. And that project is linked over Bluetooth to my Finch. So when we have this, in terms of the logistics of this, you can connect 3 Finches to 1 computer. And so I have 2 computers here in the studio, and I have 6 robots ready to go for you guys. It also works in reverse. So the sensor data from the Finch gets sent over Bluetooth to that local project, and then that gets sent over the internet about once a second to your project. So you can actually see what the sensors on the Finch are detecting. And what that means is that these Finches are actually Internet of Things objects. So if you've ever needed a way to talk about the Internet of Things with your students, set up some remote robots, and now you have an Internet of Things object. All right, so let's program these robots. So, everybody can click the link that I just clicked on, which is the, Remote Robots, Finch Arena Robots link here. And Aparna will also put that in the chat. And this is just a landing page for whenever I run a Remote Robots Playground session. It tells you a little bit about, remote robots. It gives you an orientation video. If you forget any of the things that I said in the next 2 minutes, you can watch that video. It has a link to the project for the Finch robots. And then it also has some tutorials that you might find helpful and some activities if you're looking for ideas of what to try while you've got control of the robots. So it has a description of all the snap blocks. It has some tutorials on how you would move or turn the Finch, how you control the wheels, how you control the LEDs. And yeah, these suggested activities. So let me click on this link, the big button that says link to Finches. So this is opening a remote robots project in NetsBlocks. And it may be a little hard to see. I'm going to zoom the blocks a little because Hopin is pretty, the screen in Hopin can be small. So hopefully you guys can see some of these blocks. But when I have this project open, first of all, when I clicked that link, what it did was it created this project. It sort of duplicated a project that I had, and it made a unique copy. So any change I make in this is not going to affect anything that you do, and vice versa. So this isn't like Google Docs where we're all editing the same, the same document. Every copy of this, every time you open from this link, every time you open it, it's a unique link or a unique copy of the project, which is good because you probably don't want your students necessarily, accidentally messing with each other's projects. So when I have this open, I can connect to a robot by either pressing the C key on my keyboard or clicking on this set of blocks. And so it's going to tell me in the canvas here which Finch I've connected to. So it says, in my case, connected to Finch A. And I'm going to switch my camera view so that you guys can see. I mean, this is small for now. In a second, I'll get rid of the screen share. But you can see that I have 6 robots here. And robot A is right here. It's actually got like a big peacock tail. And then I have a program that I've provided to you all that's sort of a quick sample program. And so I can click the green flag or click this set of blocks to see what happens if I run that program. And so it's going to draw a hexagon. And it's actually doing that right now. I also, if I scroll down in this program, I have some other blocks that I've put in this canvas. Now, if you're making your own Finch remote robot, you can actually change what's visible to the students or what they start with. It's totally up to you. So I've just decided to expose some of these blocks and put them in the canvas in the programming area so that you can try them out. So I can click on this, and now my tail LEDs on this Finch are green. I could make this beak red, so I could do that by clicking on that. I can make it play a note, and I can assemble a program, right? I can put these things together. I have a a couple of the sensor blocks. So like the distance sensor is currently reading 7 for me. The light sensor is reading 7. The line, yeah. And then I have like a little if statement as well that you might be able to use to make an obstacle avoider. So then if you wanted to pull in more blocks into the programming area, you can pull them from the left side. So in the motion category, I have all my movement blocks. So move forward, turn right, etc. In my looks category, I have my Finch beak and my Finch tail block. In my sounds category, I have my Finch play note, as well as some blocks that play sounds out of your computer speakers. And then in my sensing category, I've got all of the Finch sensors. And then finally, you may find it helpful to use some of the blocks in the control category. So like one of those blocks is a wait block. Another block is a repeat. And then we also have like an if statement. So essentially, if you've ever done any blocks coding before, you should see a lot of familiar blocks in control, in operators, etc. So I won't give too much more than that. Oh, I guess the last thing I want to say about this is when you're done programming, you can disconnect from the robot. But even after you've disconnected, you can still assemble a program, and then you can reconnect and test that program. So if there were a lot of you, and I see about 10 people in the room right now, and there's 6 robots, so this probably won't be too much of an issue. But if there were 20 or 30 of you, what I would be telling people would be, connect to a robot, test your program, take a look at it over through the video, disconnect, and then assemble a new program while you're disconnected, and then connect again and test it out. So, if there's quite a few people, that's sort of the way to go. When you have a classroom of students, I can also disconnect robots and make them available again for new students. So I have done this workshop with, for example, 20 to 30 elementary and middle school students. When I do that, I do have to do a little bit more robot management, and I have to disconnect robots and restart robots so that they're available again. And that's a very easy thing to do on my end. There's sort of a way to control that. So I'm disconnected. I think we're ready to go. So I've kind of done a fire hose thing here. But the next 25 minutes is all for you to try programming the robots and also to ask us questions. So ask Aparna and I questions either about programming the robots or about anything else you've seen in the presentation that you're interested in. So I'll switch off. And I guess I will pin or full screen. So you can full screen my view or pin it or something so that you can. There. All right, so you see the robots. They're here. They're ready for you. All right, robot A is going. So robot C, for those interested, has a marker in it. I think I've got a couple more markers, so I might marker up a few of the other ones too. I'm going to put a marker in robot B. There we go. All right, and I'll do the same for D. Yeah, the red one's kind of. Yep. Okay. Nice. All right, everybody's drawing their hexagons. So one challenge I might have for you guys now, so drawing shapes is a big activity that a lot of people do kind of as one of the introductory activities with the Finch. So you have the program to draw a hexagon. So see if you can draw a square or a triangle or a pentagon. So try to figure out, and there's a very good math connection there as well in terms of how many degrees to turn to draw a different regular shape. So that's just my initial challenge to you all. All right, there's still, I think, one robot available, Robot F. So feel free to connect. All right, A is looking like it might be a square, or I'll move it a little more, let it roam a little. Woo! He is going. So I do have to do a little robot management on my end just to keep things from colliding too much. Nice. Good colors on E. Yeah, you guys can see that. Little bumper cars going there. Oh. All right. Do that. Oop. So I'm going to restart a couple of them here. So robot E is now available again. And D is available. So if anybody's looking for a robot to connect to, you've got two that you can connect to right now. Oh. Hi, Terry. Let's see. Hi, Terry. Do you have a question? Huh. Let me look into that. See if I can unmute you. No, I can't seem to on my side. I could see your camera for like 1 minute. You had the video on for a few seconds, but Aparna, did you do something special? Because I know you were having trouble unmuting earlier also.
No, I think Terry has to unmute herself. I had a button that appeared at the top once you made me a moderator.
Okay.
But Terry, if you have a question and we can't figure this out, you could also type it into the chat.
Yeah. So we have about 10 minutes left. So if you're looking for another challenge, another one that we really like is the dance party. So that's where you have the Finch kind of move and flash its lights and also play notes from its buzzer, kind of in time with maybe a beat or maybe you have a song that you have in mind while you're programming it to dance. So you can, give that a try. And I'll put the dance party activity, the more formal activity in the chat as well. All right, so I see Terry asked a question about discounts. So we do offer a discount on, yes, thank you, Aparna. So we offer bulk discounts when you're ordering quite a few Finches. And then I believe at the end of the demo, we also offer a discount because those demo program robots may have been used multiple times. So you may get a 10% off discount on that one Finch. All right, we have about 5 minutes left. I'm going to turn off 3 of the robots so that the other 3 have more room to roam. So I'll keep robots A, B, and C. It does look like they're all available. So feel free to hop on and, do kind of one last program if you'd like. Oh, there goes robot A. All right, so there's about 1 or 2 minutes left. So I just want to thank everybody who's here for joining us. As Aparna mentioned, you can reach us directly. You can email us at tom or aparna@birdbraintechnologies.com. And yes, please let people know about the demo program, about the loan program, because really we feel like the best way to experience our robots is to get a hands-on experience with them. And so that's why we developed Remote Robots, is to try to make hands-on experiences work in kind of the virtual world. So thanks again for coming. And I will keep this going for another minute or two so that you can do any last bits of coding that you want to do with the robots. But for right now, I guess I'll say goodbye and thank you.